Hey, welcome to Leetcode, and today we are going to walk through this Leetcode number 203, meeting rooms number 2. Um, so let's take a look at the example in here. So we are given an array of meeting room intervals. So the first number equals to the starting time of the meeting, and the next number is the end time of the meeting. So for example, this meeting starts at time 0, ends at time 30. And we have a second meeting, which starts at time 5 and ends at time 10, starts at 15, ends at 20. And we need to write a function to figure out the minimal number of rooms required. So for example, in this case, we need one room just for this meeting. It does last for 30 time units. And for another room, can contain these two meetings because they are not overlapping. So which is the key point that we will use in the algorithm. And for this one, the two meetings, they are not overlapping, so we only need one room. As you notice that the data are not sorted, right? So actually this meeting starts at first, so the time 2, and this meeting starts later at time 7. So this question was asked by, it's a very popular question asked by many big names. So let's go through the algorithm together, and then we will walk through the code. The code is not that bad actually, but I want to walk through how we can approach that first. So let's take a look at an example in here. We have these meetings that we need to schedule. So we need at least one room, right? So the first room will be for the first meeting. So it starts from 0 and to 30. So the end time is equal to 30. And then we have the second meeting that starts from 5 and ends at 10. So we compare the starting time to the end time of the last meeting room, and it's less than that. That means that we need additional meeting room. So that meeting room starts at time 5, ends at time 10, and then the next available time for either room 1 or room 2, whichever doesn't matter. So it will be the earliest available time will be the minimum of the end time for room 2, and end time room 1 there will be equal to 10. We take the main function of the 2 times, and that will be 10. And we look at the next meeting, that's also starts at time 5, and it's greater than 5, so we need a third meeting room that starts from time 5 and ends at time 15. So right now we have 3 meeting rooms, so the next available time will be the minimum of the end time for the first room, which is 30, end time for the second room, which is 10, and end time for the third room, which is 15. And the minimum of that will be 15, which comes from the second room. And the second room is less than the starting time of the fourth meeting. So the fourth meeting can be assigned to room number 2 then. And now we have already scheduled 3 rooms. So the earliest available time will be the minimum of the first room, which is 30, and the earliest time of the second room, which in this case have been updated, now become 20. And the end time of the third room will be 15. So we take a minimum of that, and the minimum number of 15 that comes from the room number 3. And we have the last meetings to schedule. And sorry, so this one should be 16. So the earliest available time will be 15, which is less than 16, which is the starting time for the last meeting room. And we can assign, which comes from room number 3, and then we can assign the last meeting to room number 3. So in total, we only need 3 rooms to manage all these meetings. Also, basically, this is the algorithm. So the first thing is to sort these meetings. So the first key will be the starting time, and the secondary key will be the end time. And these 2 lines does exactly that, right? So we basically sorting the starting time, and then we sort the end time, because you can see for meetings they have the same starting time, and then we will sort the end time. Yeah, we don't need to create it off, and we need at least 1 room. That's why n room starts at 1, and the first starting time is just grabbing the first meeting and grabbing the first element, which is the starting time. And also the first end time will be grabbing the first meeting and the second element, which is the end time. And also we have the end time list, which keep track of all the occupied room n times. And then now we need a for loop to run through all the intervals, starting from the second element to the end. Because the first element we have already taken care of it already. And we have a variable named earliest available time. So it's basically taking the minimum as we walk through together of all the end time list. So basically this is the end time list. Is to keep track of all the end time of all the occupied rooms, and then we take the minimum of it, so that will be the earliest available time. If the current starting time is less than the earliest available time, that means that we need to have a new room. So n room will be, we have to add 1 to it. And also we need to append the current end time to the list, because we have one more room now. Again, this end time needs to keep track of all the end times for all the available occupied, all the end time for all the occupied room. And otherwise, if the starting time is greater than or equal to the earliest available time, that means that we can just take that room when it's available. So we will remove the earliest available time from the end time list first, because that room, that meeting will be finished at that point. And that's why we can remove it, and then we can assign a new end time to it. So basically it's like a swap in here. And at the end, we just return how many rooms we need in total. So it looks pretty efficient. And for time complexity, it's gonna be big O of n log n. This entirely comes from the sorting, plus big O of n, but n log n is greater than O of n. That's why n log n dominates. So it's basically big O of n, big O of n log n. And for space complexity, it comes from this n time list. So in the worst case, where if every meeting, they are not overlapping. So in that case, if all the meetings are overlapping, we need a separate room for each of the meetings. In that case, it will be big O of n, because we need n rooms for n meetings. And so for space complexity, we're gonna be big O of n. So that's so much for this solution. I hope you like it. If you do, please like this video and consider subscribing to the channel. That'll be a huge encouragement to me. Thank you so much for watching. I will see you in the next video.